So this question is all about the Haber process. What we need to do here is, first of all, is write the balanced equation for this reversible reaction. So let's remind ourselves, nitrogen is diatomic, so we can use N2 as a formula, and hydrogen is also diatomic, so it's going to be H2. Okay, so nitrogen plus hydrogen, and then it says it's reversible, so let's put our reversible symbol in to make ammonia. Now, to balance the equation, I can see over here I've got 3 lots of hydrogen, and here I've got 2. So what I'm going to do is put a 3 in front of this and a 2 in front of this. So that now gives me 6 hydrogens, and that gives me 6 hydrogens, that gives me 2 nitrogens, and I've got 2 nitrogens, so I've got a balanced equation there. They're giving you 3 marks for that equation. So the way they will award those marks, they'll give you 1 mark if all the formulas are right, 1 mark, I'm guessing, for balancing correctly, so the 3s and the 2s, and then 1 mark for putting the reversible symbol in the right way. Next question, which one shows the conditions for the Haber process? So the only one here, this is pure core knowledge stuff, the one here is option D, so it's 450 and 200 atmospheres. The iron, so the iron is added as a catalyst, and the job of a catalyst is to speed up a reaction. So that's the job of the catalyst. Right, this one's a tricky one, so take your time with this one. Explain how this reaction will work if we change the temperature and we decrease the temperature. So it tells me that the reaction gives off heat. So what I'm going to do is go back up to my equation here for a moment, and on here, that means that way is exothermic. And if you remember, exothermic means it releases heat, and therefore the surroundings will get hotter. And coming back this way is endothermic, which means it takes in heat, and that means the surroundings will get cooler. And what we're trying to do here, it says, we are trying to decrease the temperature. So we are trying to lower the temperature. If we lower the temperature, then this reaction, according to Le Chatelier's principle, says it will try and increase the temperature. If it's going to increase the temperature, let's go back up to my equation for a moment. Here's my equation. If it's going to try and increase the temperature, it means it wants to make it hotter. That means it's going to move to the right in the equilibrium. So here, I will then say that the equilibrium will move to the right. Why will it move to the right? Because it's exothermic in this direction. And what will happen there, we'll just finish this off, we'll get an increase in the amount of ammonia. But the big thing this question wants to explain how the position will change. So we said it'll move to the right because it's exothermic in this direction. Okay, this question looks like a tricky one, but if you think about it and draw out the equation like I've done here, then actually it's quite straightforward. Let me just show you a couple of ways to get into this. So compound A is dark brown, so here I've written brown. Compound B is colourless, so I put colourless over here. 2 molecules of A, so we've got 2 molecules of A form 1 molecule of B, so we've got that represented in the equation, and it tells me, as you can see here, that this is a reversible reaction. So the whole thing is inside a sealed glass tube. We've got a beaker, a kettle, and some ice. At room temperature, the equilibrium is a pale brown colour, and that would be pale brown because it'd be a mixture of molecule A and molecule B, so it's not going to be the dark brown that it describes molecule A as. Devise an experiment to show how the position of this can be affected by temperature, and the tube must not be open. So if we're going to make this reaction, the equilibrium position move, we need to change the temperature. The first thing I would do is place the test tube into a beaker of hot water. So place the test tube into a beaker of hot water, and if we do that, we'd use the kettle to do that, and that's fine. Then I would place the test tube into a beaker containing ice, so that way we're going to cool it down. And what we would do here, we would observe colour changes, and what we would see in one of those situations, it would go darker brown, and in the other situation it would go lighter or fainter in colour. Okay, I think that's the end.